Sine to the fourth, right? Cosine squared. I think this one went on the board, but I do think that there were some issues with it, so it's a good one to sort out. It's even. 4 plus 2 is 6. It's an even power here. That tells me half angle, not Pythagorean identity. Because if I tried Pythagorean identity, what would I end up with? Sine to the fourth, 1 minus cosine, 1 minus sine squared. Well, I just end up with sine to the fourth minus sine to the sixth. Well, that's not getting any better. So I think I'm just going to try 1 minus cosine of 2x over 2 squared times 1 plus cosine of 2x over 2.
Question for you. What if you were to take the 4 and the 2 out and then did a U-sub? Is that possible?
Tell me what you want me to write.
Okay, sine x with parentheses to the fourth times cosine x squared. Just move the exponent to the outside.
Just say it again.
Okay, you have sine x,
Mm-hmm.
and then parentheses to the fourth on the outside.
Mm-hmm.
And then put cosine x with a square on the outside.
Sure.
And then do a U-sub.
The problem is, if u is sine x, then du is cos x dx. And I don't have a cos, I got a cos squared. So what your guess here would be 1/5 sine to the fifth would be what you would get if you try to use sub, kind of. But the derivative of this is 1/5 times 5, so I get sine to the fourth of x times cos x. That's only one of them. I need 2 of them. That's the whole reason where odd versus even makes all the difference. If this was the problem, I'd be done. I'd say, piece of cake. Derivative of sine is cosine. It's 1/5 sine to the fifth. Or u equals sine, du is cosine x dx. So that's exactly how I identified that this is not a trivial problem. 1 is not odd. Odd ones, see, if this had been sine to the fifth cosine squared, I could have gone, no, that would have been nasty too. Anyway, don't want to do 10 problems. Yes, but that's a good question. Why can't I just do a u sub? Because the derivative, I've got one more cosine than I want. That's exactly right. Okay, you with me, Gerardo, where I'm starting out? Okay, so now, this is 2, this is 4 once I square it, right? So I'm going to do some of this so that we don't keep your tuition low by not using too many markers. This is 1/4, this is 1/2, so I got an 8 that I can pull out front. And then I've got this thing here, squared. And now there's nothing to do here but start squaring things out. So I didn't spoil it out there.
1/8.
Hmm?
How'd you get 1/8 in there on the outside?
You square the top of this, you get this squared, right? You square the bottom, you get 4. This is not squared, so the bottom, so I got a 4 out of this and a 2 out of this, make it an 8. So now all I got to do is multiply everything out. 1 cosine 2x, negative 2 cosine 2x, When does this class start?
5 minutes ago.
Okay, I'm not mad at you, I
I gotta
just
get one
figured
more
I was the
number
one that was
down.
confused. Okay, it wouldn't be the first time I started a class 10 minutes early. First times first, this times this one times this one times this one, -2 cosine 2x all squared, and last time last, cosine cubed 2x. I can combine this one and this one, and that's about it, huh? Good news is you picked one that shows every basic trig integral that you need. Now let me ask you this, Gerardo, can you do each of these? You can integrate one. You can integrate this, it's sine 2x, right, with a half out front. This, you're gonna have to do the half angle formula too again. And this one, so now what we've got is easy, half angle, again, so I'll do that one off to the side because there's a little bit of a trick. And this one is an odd one, so I'm gonna do the Pythagorean to it. So I'll do the last two for you, and then I'll let you fill in all the blanks. So, call this one star. I need the integral of cos squared of 2x. And so what I've got is the integral of 1 plus cos of 4x over 2 dx. Now why cos 4x? Because that's what the double angle formula says, right? Whatever's in here goes here double. The formula says cos 2x is, cos squared 2x is 1 plus cos x squared is 1 plus cos 2x over 2. So I've got 2x here, so it's got to be 4x up here. So now that's just 1/2 x. Then it's a sine of 4x, 1/8, because 1/8 cos 4x times 4 will be 1/2 cos 4x. That'll be 1/2 x. Okay, so that's that one.
How would that be different from losing a half?
You good? Okay. Yeah, that's a half angle. It is a half angle formula. It's just okay. And so this one, integral cos cubed of 2x, is a Pythagorean identity. It's 1 minus sine squared of 2x. It's integral cos squared of 2x times cos of 2x dx. The cos squared becomes the integral of 1 minus sine squared of 2x times cos 2x dx, which is the integral of cos 2x minus sine squared of 2x cos of 2x dx. That's 1/2 sine 2x. That's minus 1/3, 1/6 sine cubed of 2x plus k. Why? Because 1/6 times 3 is 1/2 sine squared 2x times cosine 2x times everything inside, which is a 2, which cancels with that. Yeah, I had a 3 and a 2. Yeah. So this one I did up here, right? And this one I did up here. Gerardo, you good on all of it? Of course, now I have to integrate both of these, plug both of those back in here, and then simplify the whole mess without making a sign error. Can't give you too many of those on the test on Friday, right? But you do have to know how to do every piece of this, right? I mean, any piece of this is fine.
I had a question, but this is about a different problem. I'm not sure if anybody split it up on the board, but it was sine 2n plus 1x and cosine of 2n plus 1. I wasn't really sure like how to start them to break them up.
Zach will work with you after class. The answer is, you have this.
Yes.
Okay, the answer is, this is a pattern recognition game. This means it's odd, right? So you've got, you could do it if n was equal to 0, this would be cosine of the first. If n was equal to 1, this would be cosine cubed. Okay? If n was equal to 2, this would be cosine of the fifth. If n was equal to 3, this would be cosine of the seventh. Okay? With me? You can work each of these out, and if you do, you'll see a pattern. And that's, I don't know how to do this without doing this and finding the pattern. And since this formula is in the back of every calculus book you've ever seen, then this is a participating having things in the back of a book. Some of them you can get in a heartbeat. Some of them require a real special trick. And some of them like this, it's not a trick, it's a pattern. And you just have to be able to find the pattern. And Zach worked really hard. And he showed it to the backboard one time. I would never test you. I won't test you on that. That's just one of the problems I like to throw out to. Because everybody in the class should have at least one challenge.
The pattern is just something you just want us to see, not like memorize. Well, you would memorize the pattern, like.
Well, if you want, to get this problem, you would have to recognize what the pattern is, and then be able to generalize it. In other words, you'd be able to have to say, you'd have to be able to recognize that there is a pattern to all of these, and then be able to guess, well, if n was 3, what would the pattern be? If n was 2, what would it be? That's a challenging problem. I don't want to take up class time. Yeah?
How did it get to like x2x? Like if the original problem was
This one?
Yeah, well, because it started off with sine square of x, cosine square of x.
So sine to the fourth of x is sine squared of x, or sine squared of x. That's the best way to say that. Sine to the fourth of x really means sine of x to the fourth, right? Which is the same as sine of x squared, right? So we have a formula for sine squared of x called the half angle identity. And it's that. So I have sine to the fourth, so I have this whole thing squared. And that's what I put there. Mm-hmm. Yep, good question. Okay? Okay, so what we need to do now is get up a whole bunch of problems right here. The last one